Quite often these days, we are bombarded with political rhetoric for or against the idea of global warming. Usually during these heated debates, the name carbon dioxide is tossed around like it's a devastating killer that will end us all. Many are skeptical of this notion, and rightfully so. How many people truly know about the chemical nature of this substance? Why should anyone believe anything that hasn't been adequately explained? In science, this has been figured out for a while. However, as per usual, scientists have failed miserably at effectively communicating exactly what is going on with sciencey things to the normal folks out there, those that are actually sane and aren't masochistic enough to torture themselves for the better part of a decade to learn this crap. So without further ado, here is my attempt at breaking down exactly why science says that carbon dioxide is a so-called greenhouse gas. First, this is a linear planar molecule. This means that it is a straight, rigid compound which, for all intents and purposes, exists on two planes, the x and y axes, though there technically is a z-axis. Next, the two oxygens attached to the carbon are very, very greedy. They want all the electrons for themselves. This electronegativity causes a pull of electrons away from the carbon, creating a partial positive charge on it and partial negative charge on each of the oxygens. This dynamic causes CO2 to exhibit acidity when in solution, one of the causes of acid rain, and is actually very important to the function of hemoglobin, but perhaps that can be another video. Finally, this molecule contains count them, two double bonds, and this is what I want to focus on today. These are two types of bonds, sigma and pi. This particular diagram is called a Lewis dot structure and is useful for showing bonding and valence electrons. However, it is not actually that good for showing the true nature of atomic orbitals. For that, we need a new theory, atomic orbital theory. Perhaps you've always thought of atoms as similar to our solar system, central nucleus with a circularly orbiting objects, and this is how the atom used to be visualized. However, this model has been shown to be inadequate and has since been replaced through very intensive mathematics, which I'm currently being tortured with right now. This idea of general areas about atoms where electrons are likely to be found. That's right, electrons are tricky little buggers that don't like to give too much away about themselves. These orbitals, and for CO2 mainly the s and the p orbitals, when trying to overlap and share electrons with other orbitals to form bonds, they can actually hybridize and form new types of orbitals, which is way too complicated for this little video. For CO2, the sigma bonds form first and are very strong. Next, the pi bonds are formed. These are not as strong as the sigma and are actually easily dissociated when certain conditions are satisfied. The most relevant explanation for this to occur is that of energy input. Have you ever noticed how things get hot when you heat them? This is caused by the absorption of energy. Obvious, I know, but this raises the question, how do they absorb it? So it turns out that the orbitals electrons exist in also have energy parameters. And as such, electrons can actually jump to higher orbitals when the energy barrier is overcome. Which electrons in CO2 are best able to do this? You got it, the pi electrons. When they absorb energy and jump to higher energy orbitals, the pi bonds that were helping to hold the molecule together are now not doing that job. The molecules don't like this, so the energy is ejected and the electrons settle back down into their bonds. But okay, so what? What does this have to do with anything at all? Well, actually, this has very important repercussions. After absorbing the light, which is a form of energy, the relaxing of the pi bonds allows the molecule to become much less rigid. This increase in flexibility allows the molecule to bend, stretch, rotate, and vibrate in ways which it is not normally able. These fluctuations are the result of the potential energy of the light being converted into kinetic energy. So have you ever noticed how a car's engine block gets really hot after it's been running for a bit? Well, that's because the same process is going on. And as a result of this process, heat is given off due to these pesky things called the laws of thermodynamics, which basically ensure that 100% conversion to kinetic energy is nearly impossible. But this event caused by the electronic absorption of photons isn't new. In fact, the general idea was laid out by some guy, really of no consequence at all, named something like Albert freaking Einstein way back near the beginning of the 20th century, and is actually what he won his Nobel Prize for. And this law permeates much of the modern technology we utilize today, from microwave ovens to television screens to the very device you're watching this on now. So you have these newly kinetic molecules zooming around, giving off heat. But on top of that, these molecules also re-emit photons that they have absorbed, which means other molecules are able to reabsorb them and then vibrate and give off heat. And this process continues until the energy is fully diffused. The problem is, though, that there is a continuous input of energy into the system. Yep, we have yet to figure out how to turn off the sun. Not only that, but the Earth itself is also giving off heat. Let's say you live somewhere really cold. You give off heat, right? But it's freaking cold AF. So you decide that in order to retain this heat, you have to wear some thick winter clothes. Now, these garments don't actually trap heat forever between the cloth and your body. That would violate the laws of thermodynamics. But what it does is slow down the rate of heat diffusion, allowing your body to stay warm enough to survive. Now, let's say you live somewhere near the equator, where the sun's light is most intense. Would you wear the same garments outside? No way, because not only are you giving off your own heat, but you're also getting bombarded with solar energy as well. You'd be in for a really bad time. And that's the crux of the problem. Space is really cold. So for Earth to stay warm, it does need some good winter clothes, i.e. CO2. But the sun also burns really freaking hot, and the Earth itself is giving off heat. So while some winter clothes are important, too much could slow down the heat diffusion process so much that we'd wind up like our ancestors on Venus. So that's it, guys. If you like this video, please let me know. And if you have any other ideas for me to do, also let me know about those. I really enjoyed putting this video together, so I do plan on doing more in the future. So until next time, take it easy.